Hi guys. Okay, now I would like to discuss tutorial 4, question number 4. Okay, this is the question number 4. In a magnetic circuit detailed below with all dimension in millimeter, calculate the required current I in order to establish a flux of 0.8 milliweber in the air gap. Neglect fringing effect and leakage flux. The core is made of sheet steel. Permeability of air may be taken as mu naught equal to 4 pi times 10 power of negative 7 H over M. Okay, this is the figure. The dimension of the magnetic circuit. Okay, this magnetic circuit in parallel. Okay, and we have the source here is the current injected, okay, in this coil, and with the number of turns is 200 turns. So this is the VH curve, then you can refer. Okay, for solution for the question number 4, we can divide into 3 parts. Okay, part 1, okay, here is the part 1, part 2 and part 3. For part 1, okay, the mean length is 920 millimeter. Okay, the mean length for part 2 is 459.9 millimeter, and the mean length for the part 3 is 920 millimeter. Okay, and the cross sectional area for all part is 2 times 10 power of negative 3 meter squared, and the flux that flow through this air gap is 0.8 milliweber. Okay, now we can solve for part 2, okay, because we know the value of phi2, so we can solve for part 2 first. Okay, so b2 equal to phi2 over a, then we got 0.4 t. Then refer to the BH curve, and we have to refer to sheet steel curve, and we will get H2 equal to 100 ampere turn per meter. And for this part 2, okay, the flux that flow through this part 2 equal to flux flow through the A gap. Okay, and because of that, the B2 equal to BG, and then we can calculate the HG. HG equal to BG divided by mu naught, and we will get 3 times 3.18 times 10 power of 5 ampere turn per meter. Okay, so we can move to solution for part 3. Okay, in part 3 we have loop 2. Okay, so this is the equation H3L3 equal to H2L2 plus HGLG. Then we can rearrange, so we will get H3, okay, H2L2 plus HGLG divided by L3. Then this is the value of H3, 84.55 ampere turn per meter. From this value, we can get the B3 value by referring to BH curve. Okay, so after that we can calculate the phi3 by using the formula B3 times A. Okay, time area. Then we will get 4.8 times 10 power of negative 4 Weber. Okay, then we can solve for part 1. Okay, part 1, we know the flux that flow through part 2 and part 3, and the total is 1.28 times 10 power of negative 3 Weber. After that, we can calculate the B. Okay, B equal to phi over A and 0.64 T. Then refer to BH curve, and we will get H1 is 130 ampere turn per meter. Then we can analyze loop 1. Okay, for this part 1, we have loop 1, and I equal to H1L1 plus H2L2 plus HGLG. Okay, So I equal to, the rearrange, I equal to H1L1 plus H2L2 plus JLG divided by N. Then we will get the current, okay, is 1.97 M. Okay, so this is exercise 6. Okay, I want you to try to answer this question and submit this exercise 6 through the Microsoft Teams assignment. Thank you.